This video is another in our series from the 2023 HVACR Symposium. We do have the next one coming up next year. You can always kind of stay up to date on everything symposium related by going to hvacrschool.com and then /symposium. But just look up in the top of the site where it says events and you'll find the latest details. We are going to be having it again next year, so keep an eye out for that. This presentation with Jim Jansen from Sporlan is about basically cleaning up a system using filter dryers, how to clean up a system appropriately. It's a really, really important presentation. It talks about a lot of the details that you need to know as a technician and as a contractor. And Jim is just a great guy, super funny guy, sarcastic, one of the kind of old school trainers that I came up in the trades with and just really enjoy listening to. So big thanks to Jim, big thanks to Sporlan, big thanks to ACK and Measure Quick for making this symposium possible. And I hope you enjoy this video.
I'm Jim Jansen with Sporlan out of Washington, Missouri. We're going to discuss contaminant controls today and how to clean up a system. If you have questions along the way, I'll try to answer them. I'll repeat the questions so our online audience, we have an online audience, right, Swanee? I'll repeat the question so they hear it, and then I'll try to concoct an answer that makes sense. We make a number of contaminant control products for use in a vapor compression cycle, and we're going to talk about most of them today. Sporlan's footing the bill for me to be here today, and Sporlan makes products for use in vapor compression that ranges from thermostatic expansion valves, we talked about that yesterday, up to and including contaminant controls, solenoid valves, pressure regulators, and even press fittings. We have a booth over here that you're welcome to come by and take a look. I'm Jim Jansen, that's me on the left. That's that guy right there. Usually I'm doing webinars because the COVID, as I called it, curtailed all our in-person stuff, and we went to the Zoom meeting. And how many are tired of Zoom meetings? I mean, I'm sick to death of Zoom meetings, but they really helped to keep things moving and alive. My partner in crime is John Whithouse. He's the guy on the right. John is a former design engineer, lab engineer with Hussman, and we collaborate on a lot of things. He's the straight guy, and I'm the attempt to be funny guy when we're doing these jointly. I mentioned him today. He's not here, but I mentioned him because we're going to have a booth at AHR in Atlanta next month, and you're all welcome to come by. We'll have a couple of happy hours detailed here. There's our booth number. We'd love for you to come by and see what we have to show you, and then again, we're going to have some treats at the end of the day. Vapor compression refrigeration cycle. I talked about this yesterday. If you haven't heard this enough times, we're going to beat it to death. There's four main components from my point of view, and they're highlighted here. They're highlighted here, ranging from the compressor, which provides the high and the low side pressures in the system. That works in conjunction with the expansion device that you see here. That can be a thermostatic expansion valve. It could be a fixed tube orifice. It could be an electronic device. It can be a hand valve. All kinds of things can serve that role. TXV, TEV, one and the same. And then we have the two heat transfer surfaces, the condenser and the evaporator, and then the interconnecting piping, tubing. And you could argue that the refrigerant circulating in the system is yet another component. You know, some people talk about the fans and the other ancillary controls, but if you're looking at just the thermodynamic side of it, these are the primary components. And here's a multiplex system that you might see in a simple application at a convenience store. Looks complicated on the surface, but really it's quite simple. There's only 5, if I counted them right, evaporator surfaces. And so when was the last time you went into a convenience store and there were only 5 display cases? That's a really small little quick shop. So it just kind of gives you an idea of the complexity that you might find in a big supermarket, or maybe a Walmart or a Target that's selling groceries. Think about all the refrigeration that goes into that application. And if you think about literally the miles of refrigerant tubing and all the options to introduce contamination is astounding. And that's why contamination is one of the primary culprits to thwarting the operation of any of the controls in the system. That's like the #1 problem. You hear the VRF guys talk about contamination. They're really serious about contaminant control and how they approach it. But they want to approach it from a minimalistic standpoint and not add any extra devices. Here we're talking about adding a filter dryer in various locations to help curtail contamination. And if we zoom in here, you'll see an area right at the inlet of the evaporator where we have a solenoid valve and an expansion device, and we're trying to protect those devices. And I'm going to zoom in yet one more time, and you'll see here that we have a contaminant control device right in front of the liquid line solenoid valve, which would also be in front of the expansion device. And you say, well, why do that if you're also including one here? Well, I think it's insurance policy, and I'll talk more about why that might be important. This is an actual image of internal components that we've pulled out of products that have been returned to us through our warranty department. And actual rust and contamination, sludge, and other stuff that we have found in products. Most of the returns that come to us, whether it's an expansion valve or solenoid valve or a pressure regulator, with the claim that it's failed, has been due to contamination. And this is an actual example of that. So what is contamination? Well, it's, from our point of view, it's anything that's in the refrigeration system that wasn't originally intended to be there. Now, we're kind of tough about this. There's only two things that we think should be circulating through the refrigeration system, the piping, the tubing, the components. Anybody want to take a stab at what those two things are? Yes? Oil and refrigerant. So the oil, well, welcome, guys. Yeah, I'm glad you could join us. Why don't you come a little later? So look at this diagram. I showed this diagram yesterday. This is a real simple system. It only has 5 evaporators depicted. So that's like 5 refrigerated display cases. So think about the last time you walked into a convenience store or supermarket and they only had 5 display cases. I mean, that's like a teeny tiny shop, right? You go into I don't mean to advertise for them, but one of the big box stores, Walmart, Costco, Target, and think about all the display cases that are in that store. And then think about behind the scenes, the things that the normal person doesn't see, but you guys do, all of the equipment that helps to make those cases refrigerated, helps to cool, freeze, any of the product. And think about what goes into making that happen, and then how much more complicated this diagram becomes. And when I say miles of refrigerant tubing, it literally can be that. And when you guys came in, we were talking about what are the 2 things that should be circulating through that system by design, besides contaminants. And besides contaminants, the 2 things that should be circulating, one was oil or lubricant, and the other is, you want, Stefan? Refrigerant. And besides that, anything beyond that, our contention is that's contamination. So we had a product manager that used to help us design all of our contaminant control devices, who was a real hard ass about that. Refrigerant, lubricant, that's the only thing. And so we're showing here, for protective measures, for insurance policy, that we've depicted a contaminant control device here, a filter dryer, ahead of the liquid line solenoid, which would be ahead of the expansion device, in addition to a serviceable, replaceable shell that's also in the system because of all the lengths of tubing and all of the potential for contamination to be there. Now, that product manager was really, really adamant about that, but then he's left us. He's gone to an aftermarket company that develops additives that go into the system to help stop leaks, to help do this and do that. And now he's changed his attitude about it, but it's still, anytime you add something to the system besides the lubricant or the refrigerant, you're creating the possibility for things to go awry from our standpoint. So this was an image that we showed of actual components that have come back to us that we've inspected because the component has ceased function, and the reason has been, you want to take a stab at why the reason they've stopped to work? They got crap in them. Corrosion, sludge, moisture, rust, you got it. And so what's contamination? Anything that's circulating through the system that's not what? Yes. And we have different ways to capture the main players in this problem. Moisture is a major contributor to problems in a system, and we've got ways to capture that. Acids can form in the presence of moisture and heat and other byproducts that can be in the system, and that's a major problem. And then there can also be the other sludges and debris that forms as well. Sometimes it's stuff we don't even know what it is. And so there's ways to capture that as well. Any manufacturer that makes a filter dryer has access to these three primary constituents that can be used to manufacture a filter dryer, ranging from molecular sieve, which is molecularly constructed to help adsorb moisture. And then there's something called activated alumina, and the activated thing in the name implies that we've driven all the moisture off of the product before we use it to build either a core or desiccant beads. Activated alumina is targeted to remove acid. And then carbon is a really good product to attack anything that we don't know what it is, specifically anything that might be hydrocarbon-based. And it's particularly good there. And we make cores that incorporate all three of those, as well as a few other top secret things. Now, there's always been, not always, there in the past has been some discussion over whether molecular sieve or activated alumina is better at managing the moisture that might be in a system. And in the range of moisture that might traditionally occur in a vapor compression cycle, we've always contended that the molecular sieve is by far the superior product to curtail that presence of moisture. However, if there's a significant amount of moisture, let's say the chiller barrel on a system ruptured and you've actually got liquid water in the system, you've got some major problems. And in that instance, when you're out into this realm where you're getting close to maybe the 100% mark, activated alumina does show a marked increase over the capabilities of molecular sieve. And that's something that used to come up on a regular basis. However, down here in a range where we're expecting normal moisture levels, normal moisture levels, you don't want any moisture, but where you might experience it, the molecular sieve does a fine job. And different manufacturers, Sporlan included, have made filter dryers that have had desiccant beads, loose fill, if you will. Our Parker regime like to call it compacted bead because that sounded a little more impressive, versus solid core construction. And as we go along, I mean, our mainstay with the so-called catch-all product line has always been the use of a molded porous core. We've always contended that was a superior way to handle contaminant controls. However, we always had a loose fill or desiccant bead product in the lineup until recently, and we've moved away from that. A number of reasons. One, we feel like we can control the constituents a little better and have less attrition of desiccant beads with the solid core versus the loose fill. And we also make replaceable. If you've worked on any large industrial jobs, you've encountered these replaceable core, serviceable shells. And in this instance, you've got a lot of flexibility over how you stack the cores in this product. You can put a core in that's geared towards moisture. You can put one in that's geared towards acid or to other contamination that might be in the system. You can mix and match those cores in these shells, as well as, depending on the design, you can add this nice secondary filter to get even more filtration into the system. That's intended primarily as a liquid line device. Here's an exploded view of that, and you can show all the internal components, and we do sell replacement parts for these. Here's a diagram that shows why we have some limitation for use in the liquid line, because we don't want excessive pressure drop. And in suction line applications, you can encounter excessive pressure drop, especially with that secondary filter. And this is showing here that we're advocating the use of the optional, that secondary filter for a liquid line installation. And then if you did have a need to be over here on the suction side, we have a suction side filter that can be permanently installed. And simply, we want to see large systems to be cleaned up, get them clean and dry and tight as a rule, and get to the point where the only two things circulating in the system are refrigerant and lubricant. Now, we've got three primary cores that we offer to the industry. This RCW is mostly molecular sieve and an advanced, and then this is our all-around core, which has strong acid controlling capabilities. And then over here, the so-called HH core, which I'll tell you a little bit more about that in a minute. Waxy substances used to be more of a problem with the CFC refrigerants and mineral oil combinations in low temp applications. I don't know that we see that so much anymore, but that does occur from occasion. And if you also see oil breakdown following a high heat issue, high discharge temperatures, with the advent of moving towards new refrigerants, sometimes that is an issue. And what we have found in instances where we have no idea what the contamination might be, there was a time a few years ago in the residential air conditioning market where we were seeing repeated thermostatic expansion valve failures due to some fouling agent that we couldn't identify. We had some success with removing that, and later on it was discovered that it was a rust inhibitor that was included in one of the components that was being sourced and was causing contamination in expansion devices. I don't know if any of you encountered that here a few years ago. And the thermostatic expansion valve, in addition to being a superheat control at the bulb location, is also a really good secondary filter if you don't remove all the contamination. And what we found is this stuff would pass through a conventional filter dryer and then be removed by the thermostatic expansion valve. And in some instances, you had to replace that thermostatic expansion valve multiple times. And of course, the OEMs in the business were blaming the thermostatic expansion valve manufacturers, which it had nothing to do with that. But we found that this HH core, with its carbon-based product, was able to remove that constituent, even though we really didn't even know what it was at the time. Acid is also a culprit. We do provide kits that allow you, where you can obtain an oil sample or a lubricant sample to test for acid levels. It's a one-time test kit. We're not the only one that does that, but this is good practice when you have maybe a burnout in a residential system. You can't readily get a lubricant sample, but once you remove the compressor, then maybe you can if you've had to do that. And as far as being able to see what's going on in the system, it's good practice to have a moisture liquid indicator. Major component suppliers provide these products to you, and they have a means of identifying a rudimentary level of moisture that might be present in the system, with the intention of it being clean, dry, and tight when you're operating. And then the color code on ours, if it's showing green, it's clean, dry, and tight. if it's chartreuse, how many know what chartreuse is? I mean, that's kind of, well, it's, no, that's kind of a light green, yellowy, just this side of Mountain Dew. And then if it's showing yellow, that means, it's wet. Other colors that you might see on our product, if there's no color at all, might be an indicator that there's a lot of moisture in the system and it's washed the chemical constituents off that post and it can't show a color anymore, which that's bad. Or it might show a brownish to dark shade, which might be an indicator that there's a lot of contamination in the system. And if it's just this side of charcoal black, it might have been overheated. There's a wide variety of these that we manufacture, so you've got lots of options on attaching them in the system. I don't want to belabor that. We also provide suction filters. So this can be an aid to keeping your compressor protected, and it is a device that can stay in the system for an extended period of time. Whereas a full-on filter dryer on the suction side generally is considered a temporary measure that you might undergo with a cleanup activity following a burnout and a compressor replacement. And this shows that we both have seal modeled and replaceable cartridge versions of this product.
What's the normal content of suction line?
Well, what we've done in the past, it really all kind of boils down to how dirty that system was. So let's say you had an electrical failure and a compressor and a burnout, and you've replaced it. And you want to take good measures to add a suction line filter dryer in that system to help protect the new compressor, because that's an expense. We found that going back a day or two after that suction line filter dryer installation is good practice, and then check the pressure drop across it. Depending on the refrigerant in the system, we're looking at 2, 3, no more than 4 psi drop across that, and it's time to replace it. So depending on how nasty the system was, you might install a suction line filter dryer a second time and then come back and look at it again. And then eventually, if you wanted to retain some protection, and Swanee, forgive me, I've answered this question without repeating it for the online. Do we have an online audience at this point? I got asked the question, how long would a suction line filter dryer normally be allowed to remain in the system after a compressor burnout? And I've answered that with 2, 3 days tops, with 2, 3, maybe 4 psi drop across it maximum, and then replace that device, depending on how dirty it was, with another new suction line filter dryer, and then go back and do it again. And then ultimately, you either then move in the direction of installing a suction line filter that you could presumably leave there, or you put in a stub of suction line piping. But routinely you would not leave a suction line filter dryer in permanently. Have another question? Perfect. Yeah, so the other question is, if you did install a suction line filter dryer for cleanup after a burnout, would you eventually leave one in there permanently? And the answer to that would either be a section of tubing or a suction line filter. Those would be the two options. Another question?
At the same time, would you change out the liquid line filter dryer?
You know what? That's a really good question. The question is, would you also change out the liquid line filter dryer? And if I don't run out of time, I've got a slide coming up that says, here's when you install a new filter dryer. And I'll at least get that far. So I'll circle back to that. Don't let us depart without me answering your question. And I'm not going to get out of here without answering your question, because here it is. Conditions that, if you remember nothing else from this, and if I don't get to go any further, and Swanee, how am I doing on time? All right. If you remember nothing else, this is the thing to take away. Because we get asked this all the time. When do you put in a new filter dryer? Well, these are the times that require you to install a new liquid line filter dryer. Now, we use our catchy catch-all term here, but a new filter dryer. So many systems don't even have one at all. But initial system install. How many residential systems do I see that don't have one at all? You know? You know, if the world was perfect, okay, you'd say you won't need it, but the world's not perfect. Anytime the system is accessed for repair of any kind, it's time to install a new filter dryer. The liquid line filter dryer that was out there, presumably if there was, now exhibits high pressure drop. We'll get complaints that your filter dryer has failed because there's pressure drop across it. It's got pressure drop across it because it's done its job. It's kind of like toilet paper. You use it and you get rid of it and you get some new stuff. So, the question here is, how can you determine what the pressure drop across the filter dryer happens to be? And yes, you would need to have some provisions to attach gauges on either side of it. You could maybe take the approach where if you could look at a temperature drop across it and then correlate that back and get an approximation. The best way would be if you had a pressure tap on the filter dryer and then you had one on one side or the other. Does that make sense? Yes, sir. Yes, sir. Another question.
So, temperature inlet, temperature outlet of filter dryer, is that useful?
I think the question is the temperature inlet, temperature outlet on a filter dryer useful?
For determining
If you can go on the premise that it's a single phase refrigerant stream at that point, you can make that approximation because you could take a pressure temperature chart and get close with that.
more than a couple degrees for that to change that thing.
Yeah, I'm thinking that's the case. Who you said say that?
Trevor Matthews.
Trevor, I'm agreement and complete with Trevor.
I made the mistake of not changing it before.
And get you in trouble. Comment up here was made that someone has suggested, Trevor Matthews, who Trevor's well respected, made the comment, if you got a couple of degree change in temperature across the filter dryer, it's time to change it. And my good buddy Stefan here said he ignored that one time. Got you in trouble?
Got me in trouble.
All right.
Put the temperature over the PSI.
Well, no. Pressure is by far the question. We're not going to get off this slide. Pressure by far is the indicator because pressure is going to be an indication that you've clogged the filter dryer in some ways. Now, most contaminants, a lot of the debris accumulates on the filter dryer filtering surface, and that's what contributes to the pressure drop. It's not the moisture. It's the contamination, the particulates that might be circulating in the system that then create the pressure drop. And so measuring pressure across the filter dryer is really the indicator. And it's the fact that we can correlate that back to temperature, knowing what refrigerant's in the system, that you can approximate what that is. And if you see a big temperature drop across it, you got a problem. So if I keep moving on here, if you have a moisture indicator in the system, specifically prior to the expansion device and at the outlet of the filter dryer, you can see visually whether the filter dryer is still doing its job. And if it's not, as indicated by a moisture liquid indicator, then it's time to change it again. If you've tested for acid with somebody's test kit, it's time to replace your filter dryer and then maybe start thinking about why you got acid in there in the first place. And if you've had a compressor burnout, oh my gosh, why would you change the compressor and not change the filter dryer while you're doing it? And you'll be surprised that people do that. I'm getting carried away here now, aren't I? And then during a major compressor burnout, and that's identified by what the acid level would be in the system, it's time to not only change the liquid line filter dryer, but put that suction line filter dryer in the system as well, and then take the good steps to keep an eye on that because it's going to clog up at some point and you're going to need to replace it. And then finally, and this is the part that a lot of people have a problem with, you've succeeded. You've got the thing cleaned up. or at least you think you do. Then it's time to put a new filter dryer in so that it stays that way. Now, does that answer your question on when to put in a new liquid line filter dryer?
I have another one though.
Oh,
Let's say I have a new filter dryer that's lost its protective pressure caps and it's rolling around the back of my van.
oh gosh. Okay, the question is, you've done a mobility destructive test on a contaminant control device by doing vibration tests in the back of a service truck, right? Did I paraphrase that nicely? I think I would find that suitable home as use as a paperweight someplace. My opinion. My speaker still working? You like that answer? Yeah. These things aren't indestructible. Got it. Thanks, Swanee. I see the UPS driver have a master carton of anybody's filter dryer and boom, it just makes me cringe because they aren't indestructible. You know, even if it's a nice, solid, molded, porous core, they're not indestructible. You know, you need to be mindful of that while you're handling it. And the other thing too is I sometimes get the question, we didn't address this. Once I remove those pressure sealed caps off the filter dryer, how much time do I have before I install it in the system? That question didn't come up, but oftentimes it does. I say depending on the humidity level, you got an hour or two time to get it in the system because it's doing its job and it's pulling moisture out of the ambient air. And I tell you what, down here in Florida, you got moisture in the ambient air. Some people will say I've pulled it. I haven't backed up to that, but you'll have a moisture liquid indicator. When it comes new out of the box, it's showing yellow. And they say, well, what the hell? I thought it was brand new. Well, it's doing its job. There's moisture in the air, and it's responding to that. You put it in a system that has contaminant controls, especially if you've done a good job of, the pulling the vacuum routine and all of that, it'll then show green or dry, depending on the manufacturer. Good questions from everybody. Suction line filter dryers. We've already really talked about the need for that. This is just an illustration of a screen that's going to catch hammer handles and lunch boxes. And then there are companies that have done exhaustive studies on bearing life and how that's impacted by contamination in the system based on particulate size. And this is just a good indication of you think you've got a 100 mesh strainer in a system, and well, I'm catching everything I need to acquire out of the system that might be contamination, and you're fooling yourself. It's a good measure. We put 100 mesh strainers in a lot of our mechanical devices like thermostatic expansion valves and pressure regulating valves, and that's a good thing to have, but it's not the end all and be all. You need to make sure that you get down into the lower realm of small particulates because they can do damage. And those exhaustive studies have said if you do a good job of that, you extend bearing life. Where do we have bearing life that might be of concern? In a compressor maybe? Unless it's like a fancy turbocore compressor, you got bearings that can fail. So whether they're reciprocating or scroll, there's wear surfaces that can be affected by contamination. We're just trying to make the point that it's good practice to curtail the contamination that might be in a system. And oil or lubricant is one more place in like these larger systems where they have a lubricant management system in place where we can apply an oil filter to help in close proximity to the compressor to help protect it. And we have a number of products that are both sealed model and replaceable cartridge versions that can help with that. And this just shows proximity of where you would see that with respect to the compressors. We've got some nice online presentations that talk about this at length if you're interested in seeing that. And then this is a question that comes up all the time as well, because some manufacturers elect to create Swanee, how I'm doing? Tom, I'm good? They elect to manufacture a combination filter dryer, oil filter. So they got desiccant in the oil filter. Seems like a good idea. The risk you run with that is attrition of the desiccant, and you'd be in close proximity to deliver that to the inlet of the compressor should it fail, which I don't know that that happens on a routine basis, but it could. Coupled with that, we have found through exhaustive tests that removing moisture from the warm refrigerant in the liquid line is many times more effective than trying to remove moisture from the oil stream that's being used to lubricate the compressor. So our contention is dry the refrigerant in the liquid line as best you can and filter the lubricant in proximity of the compressor as best you can. And that was the end of my technical session. So Swansea, it looks like I might finish this up. We have lots of online materials that are for free to you to download on our website. You can contact our tech support. You can talk to a human. We've got multiple folks that are manning our tech support lines that will help you with problems. They've been in the industry a long time, and some of them are more personable than others. One of them has got a bad habit of, if you call him and he asks you, okay, what's the high and low side conditions? And I don't know. What's the refrigerant in the system? I don't know. What's the superheat at the sensing bowl? I don't know. It sounds like you don't know a damn thing, and when you do, call me back. He's been known to do that. It's not me. We've also got our tech support email. I sometimes answer those. We are very serious about trying to help folks. I'm also, if you know, Parker has something, Parker owns Sporlan, not the other way around. Parker has something called See Parker. It's a 24-hour hotline where you can call Parker on a Saturday night and you've got a problem, and they, I'll give you 3 guesses who they call. It's me. So I get the call on Saturday night or Sunday night. I know if I get that call, it's a power plant someplace, they're doing a shutdown, and they've broken something that Sporlan's manufactured 20 years ago, and they want a replacement on Saturday night. Well, they aren't going to get it on Saturday night. But I'm the guy that has to explain that to them. And you can go on our website. You can go to our YouTube channel, and we've got over, we're getting to where we're building a library. We've got a full supermarket seminar talking about our products and how they work, how to troubleshoot them, that you can watch for free. Thanks, Swanee. Does anybody have any questions? Yes, sir.
I had a question about filter dryers facing the wrong way dangers. Double filter dryering, is it really, I've seen both happen and systems live forever.
Okay, I'm not sure I understand your question.
The directional flow of the filter dryer liquid line is supposed to face the
Right, right.
I think that's backwards.
Oh, okay. Question is, if you install a traditional filter dryer in reverse, my contention is usually there's a final filter. So we say they're a filter dryer, they're really more of a dryer filter. So you're going to tend to foul the filter portion of it, possibly. I don't. If I'm going to say it's if I have time to go back, I got a diagram that if I get to the cutaway, flow should be coming into it from here. The outside perimeter of that core acts as filtration. And then we got a final filter in it. That final filter will get clogged if you put it in reverse.
You have more area on the outside.
Yes, yes. So you would prematurely foul the catch-all or the filter dryer if you installed it in reverse. Now there's bi-flow filter dryers. Now that's different. Now those got a device in there that directs the flow accordingly. Did I answer your question? One more question. Do I have time for one more question?
I was told that you don't need a suction line dryer, you just put some acid neutralizer in there and magic power.
Okay, all right. The question is, you don't need a suction line filter dryer of any kind. You just put acid neutralizer in the system and let that circulate. How many of you remembered what I said, the 2 things that should be circulating in a vapor compression refrigeration cycle? What were they? Refrigerant and lubricant. And what's that? That's a third one. Did I answer that? Oh, thank you. Hey, you know what? There might be times where adding a third constituent is the right thing for a given system in unusual circumstances, but I say as a rule, that's a Band-Aid.
All right. How does a filter dryer absorb the water out of the liquid refrigerant without, what's the chemistry in it?
Okay, you're getting into trick. So the question is, how does a filter dryer, and from what I'm told by the chemist, the correct term is adsorb moisture out of a flow stream of refrigerant? Well, it's friggin' magic, is what it is. The desiccants are specifically designed to have an affinity for whatever constituent you want them to attract. And so there's pore spaces on a molecular level that are the right size for the molecule of acid or water or whatever it happens to be. And in a way, it traps it in there in such a manner that it doesn't create a pressure drop because of that constituent. So I can't get into, because I'm not smart enough to get into every ramification about it, but like take molecular sieve, it is specifically formulated on a molecular level to have an affinity for moisture, and it just attracts it like crazy. In fact, if you got molecular sieve in an open bucket, it just draws the moisture out of the ambient air. It's crazy. And that's the best answer I can give to you.
Big thanks to Jim. Big thanks to Sporlan for their support. They came in and were a sponsor at this year's event. And it's just great to see the community of HVAC coming together. A lot of these brands and folks who I've been working with and using their products for so many years. And it was great to have Sporlan at the symposium, and we hope to have them and many others next year. To find out more, go to hvacrschool.com/symposium, and you can still go on now and watch all of the different classes and get the various materials from the symposium from last year. For a small nominal fee, you get the full virtual ticket and can watch it there at hvacrschool.com/symposium.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.